I'm Dale Newnham, and I'd like to demonstrate a dashboard I've developed using Power Pivot. I have a few slides as background first, and then I'll move to the demonstration. You might ask why I use Power Pivot, so here are some of the reasons that I feel are important. It handles massive volumes of data, in fact many millions of records. You can link data from multiple sources and formats through a relational model. It performs complex calculations much faster than spreadsheets, and supports dynamic data visualization as data is stored in memory, which provides a fast response time to users. It's stable and reliable, especially compared to a spreadsheet, which can become fragile when developing complex tools and dashboards. It's also flexible and easy to modify, and there's a shallow learning curve for people that are experienced Excel users. It's possible to get quick results, and it's also free. One dilemma that we often face is whether to develop a quick solution in a spreadsheet or embark on a large-scale business intelligence project. The blue line represents a typical BI project where initial development costs are high and lead times are long, but there are efficiencies over time due to automation and the robust nature of the solution. The green line depicts the initial low costs and quick startup of a spreadsheet-based approach, but costs increase over time and problems are frequently experienced, including an inability to scale. But Power Pivot can offer many of the benefits of both approaches, with quick startup and a stable platform that is secure and automatically refreshed. I'm not claiming that this is the right tool for every BI problem, but it is very powerful. In trying to decide what to dashboard for this demonstration, I felt the subject should use public, not proprietary data. It should be interesting and engaging to many people, and be complex enough to demonstrate the tools and techniques needed to solve real business problems. To find the right topic, I performed a thorough search of high-quality news sources. Well, actually, I spotted this fine newspaper on the checkout line, which had some interesting topics. Celebrity brawls on social media looked interesting, and sports statistics showed promise, but this story on bird shootings at JFK Airport drew my attention. I'm a big Harry Potter fan and found it shocking that anyone could shoot Hedwig the Snowy Owl. I mean, how could you? But there is a serious side to this story, with the best example being Captain Sully's ditching of Flight 1549 in the Hudson after striking a flock of Canadian geese, thankfully without loss of life or serious injury. That's if you exclude the geese, of course. So this problem raises a number of interesting questions. How many birds are killed by planes? And how many people are injured or killed due to bird strikes? Is this problem getting worse, or is it better over time? And is bird population distribution a factor? Does the volume of air traffic have any effect? And which airports and regions are really responsible for this problem? Which species of birds are the most impacted? And really, most importantly, what about the snowy owl? So to answer this question, we need data. I sourced bird strike data from the FAA, air traffic data from the Bureau of Traffic Statistics, and bird population data from the US Geological Survey. These three sources from a database, a spreadsheet, and a text file are linked in Power Pivot through a series of tables in a relational model. We work through the process of extract, transform, and load, ETL, to allow us to present the data in meaningful ways to users. So I'll switch over to the dashboard now and review the general layout. We have critical metrics in this top row, you can see here, and 7 charts that visualize bird strike, bird population, and air traffic data. The slicers over here on the right allow users to drill into specific areas, and also the 2 tables on the bottom rank states and species and provide key performance indicators. So let's see if we can answer the questions we posed earlier. The first one was, how many birds are killed by planes? So this chart over on the left here, you can see over a 12-year period we have data for 2000 to 2012. Almost 211,000 birds were killed. That's summarized here at the top. And the rate is actually increasing from 9,000 in 2000 up to 14,000 a year in 2012. You can see this is the axis on the left-hand side, shows the bird count. How many people are injured or killed due to bird strikes? The red line here really shows people injured, and you can see that that peaked in 2001 with a total of 12 people injured, and more recently it's hovering around 3 people. People killed, which is represented by the orange crosses, is lower, with a maximum of 5 fatalities in 2008 and nothing in recent years. So is this problem getting worse or better? Birds appear to be faring worse, as you'd think, based on this blue line. And people, in recent years, injury rates for people are lower with no fatalities. So it's getting worse for birds and better for people. Is bird population distribution a factor? Bird population appears to be dropping. If we look at bird sightings and bird sightings by state here, we can see that it's dropping over the 3-year period that we have data for, 2010 through 2012. And this is true for states with the highest bird sightings. That's Texas, California, and Louisiana. Although California, if you look at the squares here, does appear to have a more stable population than a lot of the other states. Does the volume of air traffic have an effect? This chart here shows air traffic movements in total. And you can see at the top here we have over 250 million movements. That's takeoffs and landings of planes over the 12-year period we've analysed. And that peaked at about 22 million in 2005. Overall, it's relatively stable, I think going down to 18.5 million in 2012. You can see how this is broken down by airport in this chart below, with Atlanta, Chicago, and Washington, D.C. with the highest volumes. So which airports and regions are really responsible for a lot of this problem? You can see this chart over here on the left. This breaks down bird kills by airport. And you can see that Denver, Dallas, and Honolulu are really the airports that are experiencing the problem the most. If we select Georgia and Colorado from this slicer here, I'm just drilling into these 2 states in detail. You can see that Atlanta and Denver airport traffic is more significant than the other airports in these states. So what I'm going to do is further narrow down the focus to just the Atlanta airport and Denver. So you can see every time I select the slicers, all of the charts basically refresh to focus in on just the data that we're interested in. And in the slicers you can see that the text color and the button color actually represents whether we have data or not available. And that's one interesting thing here is if we look at the species slicer down at the bottom, the species where we have data, you can see the text is dark, and where we don't have data, it's actually light. So that provides us with some visibility as to the type of data that we have and the overall problem. So as I mentioned, although Atlanta has a lot more traffic than Denver, Atlanta seems to have a lot fewer bird kills than Denver does. And you can see by comparing this blue line with the blue area, with the red line and the red area. So the impact to birds is far less in Atlanta. The bird population in Colorado, though, is a lot higher than in Georgia, but not, massively so. But it does look like there is something interesting here. The metrics in the table below on the left show that the bird kill rate is actually 3 times higher in Denver than in Atlanta. That's these 2 numbers here. So which species is most impacted? I'll clear these slicers here. I'll just clear the airport slicer and the state slicer. And we can see then basically all of the data within the analysis. And you can see that the European starling and the mourning dove, that's an unfortunate name, and gulls are really the top species that are experiencing kills. Although some birds, these unknowns, can't be actually identified because they've been processed through a jet engine, so it's hard to identify the species. So anyway, what about the snowy owl? We'll go back to the species slicer here on the right, and what I'm doing is just scrolling down to the snowy owl. I'm going to select the snowy owl button, and again it will adjust the charts over on the left hand side. What you'll notice is that there are no sightings of the snowy owl, which really shows what a rare and important bird this is. But there are a total of 93 owls killed over the 12-year period. Boston, JFK and Bangor, Maine are the main airports where kills are experienced. And JFK is actually the airport which was covered in the newspaper story that we showed earlier. So let me switch back to the slides to confirm that we've answered all of the questions. Well, those were the 8 questions. I'm pretty sure that we did cover all of those. So in summary, I hope that I've demonstrated that dashboards can help answer complex business questions, and Power Pivot is a powerful tool that can compete with large-scale BI applications. Sophisticated and usable tools can be developed in days and weeks rather than months and years. So that concludes this demonstration. Many thanks for your time.